Hello and welcome to my YouTube channel. Today we are going to see State Board Class 8 Science Chapter number 6 Composition of Matter. In our previous topics already we have studied about the matter. We studied about that each and every matter is consists of an atom. We studied about the subatomic particles like a proton, electron and neutron. Now, in this particular topic, we are going to learn about the composition, means what actually the matter consists of, how they are made actually. As already we know about the matter, the three different states solid, liquid, and gaseous states we have. Now, when we talk about this solid, liquid, and gaseous, you can see over here about the inner particles. They have given the pictures. In a solid, when we talk about, they are very compactly arranged. Means in a simplified picture, if I want to show it, the matter, they are very closely arranged. They are very closely arranged. Very less vacant space we have in between this particular atoms. Whereas when we talk about in a liquid, you can see here vacant space is but little bit more as compared to the solid. But when we talk about the gaseous, you can see the particles are freely moving. They are very far from each other as compared to the solid. In a solid, they are very compactly arranged, very less space. Means simply if I am saying that one bucket filled with the sand, in a sand the particles are very close to each other, so weight will be much higher. But when same if I'm saying fill it with the balls, cricket balls, then what will happen, the vacant spaces will be more. And if I'm saying fill it with the footballs, then the vacant spaces will be much higher as compared to the all the previous ones. So in that particular case, what we can draw out that particle of a sand or the cricket ball or the footballs, we can consider them as a particles. In a solid state, they are very closely packed, closely arranged, and that's why the solids are having a more weight as compared to the liquids and the gases. Another part when we talk about this three different solid, liquid, and gaseous, they have given a table over here. Let's discuss the table. Fluidity means how fluid they are, whether they are moving on the surface, then the rigidity, plasticity, and the elasticity. When we talk about the solid, they are rigid, plastic, and elastic. Means the solid, if we are having any particular material or the matter, if we keep on the table, it will remain in the same shape or the same size. Why? Because it is a solid, it's having a rigid body. Fluids, they are fluid. Gaseous, they are also fluid. Means they are moving with respect to the surface and the container in which they are placed. Volume, we have a definite for the liquid and the solid, but it is indefinite for the gaseous because it depends on the volume of a container in which they are kept. Like if I am talking about the perfume kept in the perfume bottle, it's very small in a size. That perfume is filled inside it, but as soon as we spray it, what happens, the fragrance of that perfume gets spread in the entire room. And if the doors and the windows are open, then the fragrance can go beyond the room's boundary also. Means through that window and the door it will go out of room. Means the gaseous, they are free to move and the volume is not fixed. It depends on the container in which they are present. That's why they have mentioned over here as an indefinite. Shapes, we have a definite shape for the solid. If we have a solid like apple, it's a solid. If we will keep it, it will remain as it is. But when we talk about the liquid and gaseous, they don't have their own shapes. It all depends on the container. Even liquid, if I'm talking about the water or a milk, they take a shape of a container. If it is placed in a bowl, it will take a shape of a bowl. If it is placed in a glass, it will take a shape of a glass. If it is kept in some other dish, it will take a shape of that. Means they don't have their own shapes. Only solids are having their own shape. Compressibility means how we can compress them. Solids we cannot compress. If you have a chalk piece or the apple, as taken the example, if you will press it, it will break out. Means what? They don't have a compressibility. Whereas the liquid we can compress. We can compress and fill it in our containers. Gaseous, it's very high. We can compress them like petroleum gas, the LPG which we are using, the liquefied petroleum gas. It's filled under pressure in the cylinder. Intermolecular force, we have strong force in the solid because they are very close to each other. The particles are very close to each other, and the moderate in the liquid and very weak in the gaseous. Distance between particles in minimum we have in the solid because they are very close. Moderate means a little bit far from each other, and very large in the gaseous because particles are free to move, so the distance between particle increases rapidly. Further, when we talk about the name of the materials, you can see over here the name of the materials like a water. It is H2O we have for the water. Carbon is C, oxygen is O2. Air is a combination of various gases. Aluminium, it's a metal element we have. Brass is an alloy, the mixture of various metals. Then the carbon dioxide, we have a compound CO2 gas we have. So this type of a matter we can discuss at a later stage. Before that, we have to talk about the matter in a three different ways, and they are nothing but the element, compound, and mixture. This element, compound, and mixture means what? If you remember, in the previous chapters, we had already studied about the atom. Each and every matter is made up of atoms, and these individual atoms they have their specific names. Different matter is consist of a different kind of atom. Atom is common thing, but the name of that atom will be different. Like iron, we have carbon, oxygen, nitrogen, hydrogen. These are nothing but what the elements. They have a different structure for the atom. Structure in the case means it will be only the electronic configuration they are having different. The basic construction of the atom will be same. That is the nucleus and the electrons in the shells. K shell, then the L, then M, then N, and so on. So when these elements we are talking about, the elements means the basic free atoms. When these elements or the atoms they are chemically uniting or combining in a definite proportions, then it forms the compound. Like one carbon and two oxygen. One carbon and two oxygen. When it combines, it gives us CO2, which we call as a carbon dioxide gas. This is a carbon dioxide gas, CO2. Same way, if I'm having two hydrogen, one oxygen, it combines and gives us H2O. It's not chemically or the balanced equations. I'm just giving you the concept how actually the compounds are formed. They are chemically combined. When we don't have the chemical composition of the atoms, they just merely mixed with the two compounds or the two elements or the two atoms. If they are just mixed, then it's called as in mixture. It's called as in mixture. Like air is a best example of a mixture. In air we have water droplets, we have nitrogen, carbon dioxide gas, we have a carbon monoxide gas, we have oxygen, we have a various gases present in the air, but they are not chemically combined, they are just a mixture. So the we have a matter in a three different ways. The one we call as an element, where we have a free matter, then the compound where the chemically combined atoms we have, and then the mixture. They are just mixed together. It will be much clearer when we will talk about this particular table. You can see over here we have the element that is a nitrogen. Only a single type of atom is present, that is a nitrogen. You can see over here the compound nitrogen dioxide. Nitrogen dioxide molecules we have where one nitrogen is getting linked with the two oxygen. Same way when we talk about the mixture of nitrogen and nitrogen dioxide. Here they are not chemically combining the nitrogen and nitrogen dioxide. They are separate, but they are having a mixture of it. Oxygen molecule, they have taken another example, nitrogen oxide, they have taken one nitrogen and one oxygen, and then a mixture of nitrogen and oxygen. You can see what actually they are. Constituent substance of element is only one type of element will be there. Then constituent substance of a compound is only one, and it is that compound itself. Here constituent substances of a mixture are two or more elements and or compounds. It can be anything, mixture of atoms, elements, or the compounds. All the atoms or molecules of an element are alike, means they are same. All the molecules of a compound are alike. Here atoms, molecules of a mixture are of two or more types. All the atoms in a molecule of an element are alike and are joined to each other by chemical bonds. Here the constituent atoms of a molecule of a compound are of two or more types and are joined to each other by chemical bonds. On the other side, when we talk about the mixtures, the constituent molecules of mixtures are different from each other and are not joined by chemical bonds. Same way, the further when we talk about the atoms, molecules of different elements are different. When we talk about the compound, the proportion of a constituent elements in a compound is constant. Proportion is constant, that is most important part. Like when we talk about the nitrogen dioxide, each and every molecule of compound will have one nitrogen and two oxygen. That's going to be fixed. Whereas in a mixture, the proportion of a constituent substance in a mixture can change. Means if I'm talking about the air, different places are having a different composition in the air. Some place carbon dioxide is more, some place oxygen is more. So it can be a different at a different places. Further, that is the element compound mixture, a schematic sub-microscopic picture and characteristic they have given over here about the water, a compound, milk as a mixture. How the water is a compound? Because when we talk about a compound, we have a definite proportion. So water is having a definite proportion. Two hydrogen and one oxygen. That's why the water is called as a compound. Whereas when we talk about the milk is a mixture because in that we have a different kind of proteins present in the milk. Like you can see they have given a composition of a milk that is a water, lactose, fat, protein. A few more natural substances are present in the milk and the composition changes for it. The different milk is having a different composition and that's why the milk is called as a mixture. Next we have a types of element. Types of elements can be divided into a different categories. In that the major category what we have as a metal and non-metal, and the third one as a metalloid. Metal and non-metal are the major classification of the elements. Some materials like iron, gold, silver, copper, aluminium, these are the substances. If you will polish them, they start to shine. So the materials which start to shine on polishing is called as the metals. Which don't shine, they don't, or they are called as the non-metals. Here they have given, on the basis of this, they have given a table that you can complete. Then further, that elements having a shiny surface are called as the metals. elements that flatten on hammering metals, elements with a dual or the dull surface is a non-metal, elements that break on hammering is a non-metal. So these two are the non-metals and these two are the metals. In the next lecture, we will talk about the compounds and type of compounds.